continue with the translations. So we have this, we already moved things left to right, up or down. Now we're going to flip them, or we're going to dilate them, which is shrinking or enlarging. So you got all these parent functions, okay, that we're going to work with again. Remember, up or down is adding or subtracting the value at that's outside, not attached to the x. Left or right is adding or subtracting or adding the number in with the x. Okay, so we went through these examples. Hopefully you had some time to practice those. Now we got a new thing. And the first thing we're going to talk about is reflecting. Reflecting, if there's a negative that's out in front, that reflects the graph over the x-axis. If there's a negative inside with the x, that reflects the graph over the y-axis. Let me show you some examples on delta math, okay? And you can write these examples down in your notes. Okay, so let me go back and get you a new problem here. Let's get this one right here. Let me find one that we could do it with. Okay, so take this problem right here. This negative, it's outside of the x. If you go back, that one reflects it over the x-axis. Notice this negative is on the outside, reflects it over the x-axis. So if we take this one, what we can do with these points is we can drag it. We say, oh, if I want to reflect this graph over the x-axis, there, I reflected it. Now I do have to do this -4 plus 3. The -4 moves the graph to the right 4 units. There, I moved it to the right 4 units. This +3 moves the graph up 3 units. So what I've done with this graph is I've reflected it over the x-axis, moved it to the right 4 units and up 3 units. And let's see if we got the right answer. See if we get that magic check mark. And it even tells you what you need to do with it. So let's take a new problem. This one, the negative out in front, reflects it over the x-axis. Okay, that's that negative that's out in front, reflect over the x-axis. The negative on the inside reflects it over the y-axis. So we're going to take this, we're going to reflect it over the x-axis, then we're going to reflect it over the y-axis. And there's our new graph. There you go. Reflected over the x-axis, reflected over the y-axis. You'll get some practice at this. Delta Math does a really great job at allowing us to manipulate graphs in a really interesting way. Take something like this one. This is this negative out in front, reflects it over the x-axis. This negative right here reflects it over the y-axis. This -4 drops the graph down 4. So, if we reflect this point over the x-axis, if we reflect it over the y-axis, now we've reflected over the x, we've reflected it over the y. Notice when we reflected it over the y, it really didn't change it. That's because this graph is already symmetrical about the y-axis. And then we just have to move this graph down 4 units. And if we do that, we should get the right answer. So reflected over the x-axis, reflected over the y-axis, shifted it down 4 units. Okay, the next thing we can do is we can do what's called a dilation. We can narrow or widen the graph. Okay, just as a side note, if a is greater than 1, it narrows it. If a is in between 0 and 1, it widens it. But really what you want to think about is to do this, here's the hint. Take the original graph, take the parent graph, and multiply the y value by that value a. Just multiply the y value by a. Show you what I mean on that. Okay, so we're just going to multiply the y value by a. So I got to get a problem for you. Let me go back here. Let me go to these functions here. Okay, so let's take this one. Now we really have to kind of think about what this one is. So what a actually is on this value. So if I take y, I'm going to write this down, and then we'll kind of talk about what we do on this one. So when we're thinking about how this graph works, if you look at this function, it looks like this. Manipulating this one, you got this negative, you got the 1/4 here, you got the x there, and the plus 3. Well, so just so you know, the square root of 1/4 is 1/2, because the square root of 1 is 1, the square root of 4 is 2. So if we kind of talk about all the parts of this one moves it up 3. This one flip over the x-axis. This is you multiply y values by 1/2. Okay, so let's do all those things with this particular graph. Okay, so let's take this point right here, 4, 2. If we multiply all the y values by 1/2, I would bring it down to there. If I then flip this over the y-axis, over the x-axis, instead of being there, it would be right there. If I move this one up 3, I would go up like this. So I just did all those 3 parts. Hopefully that's the right answer. Let's check. Make sure I got it. There we go. I reflected it over the x-axis. It's a horizontal dilation. They talk about doing a reciprocal. Okay. But we'll kind of talk about what we can do with that and how that looks. But I would just encourage you to do what I did on there. And then this goes up 3 units. So let me show you a new problem. Let's take a problem. Let's get a number like this one. Let's try this one. So I'm going to write this one for you. Let me take something like this one right here. Let me write it. So y is equal to 3 square root of negative x plus 1. So let's talk about this equation, and let's just first up map out what this whole thing does. This makes it go up 1 unit. This flips it over the y-axis. And this multiplies the y values by 3. Okay, so let's do that. Let's multiply the y values by 3, flip it over the y-axis, and move it up 1. So let's take this value right here, 1, 1. As a y value of 1, multiply it by 3, now it's up there. Flip it over the y-axis. Instead of being here, let's flip it over the y-axis. And then let's move it up 1 unit. And let's see if I moved it to the right place. And there we go. So hopefully that makes some sense. Hopefully you can do that. Let me know if you have any questions.